Okay, so I wanted to talk a little bit more about calculator use for binomial distributions, because after all, you're going to be using your calculator for pretty much all of this. Okay, so, the question is, what if I had changed that last example? In the last video, it says, what is the probability that exactly 15 would have high-speed internet? Oops. What if I change it to at least, or at most, or something like that? Then the way we use our calculator changes, so we might as well just go ahead and combat that right now. So when we're asking for exactly, we're using this, Binomial Cdf, NPX, right? For the rest of them, if it's at least, at most, less than, greater than, we're going to use the Binomial Cdf, because what the binomial does, this function does, is it accumulates the probabilities. It sums them up. And I'll show you, a hand example in a second. So the CDFs are going to accumulate those probabilities. So, you want to think of this when you have no more than X successes, or at least X successes, or something to that nature. Now, when you've got greater than or equal to, you're going to take 1 and subtract from it the result of the binomial PDF. Here's an exception here. You're going to have to subtract 1 off of whatever value this is. So, from the last example, same example, except I changed exact to at least. So, what's the probability that we have exactly 15? Well, we already worked that out in the last video, right? N, P, and then X was 0.241. Okay? If I want to find the probability that the random variable took on at most 15, well, then I'd have to compute P of X equals to 0 plus P of X equals to 1 all the way up to 15, and I don't want to do that. So rather than that, we're going to use the binomial CDF, and you're going to do 8.8515, and what that's going to do is it's going to add all that stuff without you having to do it. It's going to compute it all and sum it all together, and you'd get 0.521. What if I wanted to figure out, at most but not including, or up to but not including 15, less than 15, however they're going to word it? Well, that's still a binomial CDF, but here is where I've got to subtract 1 off of the 15 because I'm not including it. So you see I get a different probability. If I want to be greater than 15, it's 1 minus binomial CDF, and I get 0.480. Now, if it's greater than or equal to 15, again, I need to compute all this stuff by hand, and I don't want to. So, rather than that, we use 1 minus the binomial CDF, but you notice here is where I'm subtracting 1 from X, because I want to subtract everything, the probability from X equals to 0 all the way up to the probability of X equals to 15. So it's 1 minus the probability of X is less than or equal to 14. And that'll give you what's left. Okay, so that's 0.720. So I just wanted to go over that. Know these different functions in the calculator, and the only time you're going to use the PDF is when X equals, or they want some exact probability. Okay. Finally, one other thing, I forgot about expected values, so I'm going to throw that in here. Here's a little example, and a lot of times they'll ask you a question, is the game that's being played a fair game? And a game is considered fair if the expected value of the winnings is 0. So an example would be Tom tosses 3 fair coins. He wins $9 if he gets 3 heads, $5 if he gets 2 heads, $2 if he gets 1 head, and if he doesn't get any heads, then he pays $30. Is that a fair game? Okay, so, you can write out your sample space if you want to. You really don't have to, but, it just helps to see it, I think, sometimes for some of you. So here's the sample space of all the possibilities. There's 8 different possibilities, okay? And I'm letting A be the amount gained or lost. I'm either going to earn money or I'm going to lose money. Win or lose, right? So, again, the probability that I win $9 means that I have to get 3 heads. It's the same as the probability of getting 3 heads, so that's 1/8. The probability that I get $5 is the probability of any one of those combinations. So there's 3 out of 8 possibilities. If I want to win $2, then that's the probability of any one of those three. So again, it's 3/8. And the probability that I'm going to have to pay $30, well, that's the probability I don't get any heads at all. So I get a tail, tail, tail situation. That's 1/8. And if I add all of those up and multiply them by the respective winnings, so $9 times the probability of me getting of winning that $9 plus $5 times the probability of me winning $5 and so forth, I get 0. And since it's 0, I can say that the game is fair. So make sure you know this too, because I don't know if it's on your semester exam, but it'll definitely be on your IB exam.